Welcome again to industry-related manufacturing technology. This is for the Industrial Technology Stage 6 syllabus. We're specifically looking at timber products and furniture technologies in the preliminary syllabus. We're under the headings of materials, timber and timber products, and we're now looking down at manufactured boards, which is the fifth dot point as you work your way through this area of the syllabus. Now, in terms of what's required here, we're expected to learn about manufactured boards, okay, what they are, a little bit about them, and how we use them. Specifically, we need to know about plywoods, MDFs, and particle boards. Now, by the end of this process, you need to be able to think about the properties of manufactured boards and apply them to your practical project. So thinking about their use in your major work is really what you got to think of here, and in the projects we work through in year 11. Then you also need to be able to describe the range of boards that are available. I've seen quite often in the HSC, they might ask you to describe the differences between different boards. They might give you an image of a board and ask you to determine what it is in multiple choice, things like that. So let's get started. Basic understanding, solid timber versus manufactured board. You're probably very familiar with solid timber. It is a natural structure. It is a tree that's been chopped down and it's now a solid board or solid timber piece. It can have defects, probably has defects, and those defects could be things like knots, could be things like insect or fungal attacks. It could even be defects from seasoning. And I think if we're thinking why we use real timber boards, they look really nice. And you can get timber in a range of different colors, a range of different characters, strengths, etc. So depending on your application, there is lots of species of timbers out there. Problem with using timber is that sometimes the timber takes a long time to grow, okay, particularly if we're thinking like old growth timbers, or even some of the hardwood species, they take a long time to grow. And so when the demand to use the timber is greater than the supply that's available, then that's obviously not great for the environment. So there are lots of things happening worldwide to try and protect timber species. Things like actually making timber species endangered, things like having limits on the amount of specific species that can be imported into the country. I believe that, for example, New Guinea rosewood, a beautiful colored, pinky colored timber, is actually limited to how much of that species can be imported into Australia. And if you are to use it in Australia, you actually are meant to be provided with a certificate basically that says that this is legally imported timber, because this is one of those species that's been so heavily illegally logged over the years that it's becoming extinct. So solid timber, we're running out of it. There are species like pine that we grow in plantations, and so we've got that sustainable setup. But when we're thinking about our projects, quite often people deviate from pine because they're looking for timber to meet a specific brief, and so that's what we've got to consider. The other thing with solid timber, limited to the size that's available. Trees, they can be quite tall, but generally speaking, the longest lengths of solid timber boards that I've been able to find are around about that 6 meter mark. And while that might sound absolutely enormous to you, realistically, I've only seen that in things like treated pine for construction level projects. When I'm thinking about boards that I would use for furniture making, and I think about what boards I've seen, we're usually looking around about that 2.4 meter mark would be a fairly common length. There are bigger lengths available, but they become really expensive. So got to take those sorts of things into consideration. And that's where manufactured boards actually is so important to our industry. Now, let's think about them. Manufactured boards, manufactured, they are man-made structures. They are not real timber boards. Now, when I say not real timber, they are made from real timber and they have real timber in them, but they don't grow the way that we use them. They're generally a little bit cheaper because the manufacturing processes enable companies to take bits of timber that normally wouldn't get used in furniture making because maybe it's not good enough quality or maybe it has too many defects to be used. And they actually get to use those sort of offcuts in a sense, or those waste bits, to make these manufactured boards. Now, it's not always made of waste bits, but it's definitely an opportunity that exists. One of the other benefits of manufactured boards is a lot of those defects we learned about in our last series, when we're looking at warping, when we're looking at bowing, when we're looking at cupping, all of those sorts of defects are almost entirely eliminated when it comes to manufactured boards, and that's one of their greatest strengths. The other benefit is they can be much larger. Okay, so that's one of the benefits we've got with the manufactured boards. They can actually come in quite large format sizes, and because they come not only in large lengths but actually in large widths, which is its true benefit over solid timber boards, you can actually get away with making a project with less physical pieces of timber because you don't have to make as many joints because the boards are already wide for you. Your only real limitation there in terms of width is the machinery that you've got available to work with. Okay, so let's have a little bit of a dive in and get started with MDF. Now, MDF is a fiberboard. Now, there is MDF, medium density fiberboard. That's the one we need to know about here. But there's also another one called HDF, or hardboard, hard density fiberboard, or high density fiberboard, sorry. Essentially the same thing. It's just all about the size of the fibers that are used within the material. So you can see I've got an image there of hardboard. I've put the hardboard there because it's a little bit easier to see. When we look at MDF, it tends to just look like cardboard. It's not as easy to see the little fibers in there, but you can see the fibers here. It's an engineered wood product. There is no grain in this product, and it's used all the time in furniture making and all the time in construction, even for things like surfaces of doors. Now, when we're thinking about MDF, huge amounts of waste timber, so timber chips, for example, mulched down, broken down into their individual fibers, tiny little fibers floating around inside a factory. They get compressed down into these really dense sheets of material, and because of the way that they are compressed, the fibers are actually randomly arranged. They're all pointing in different directions, which makes it an extremely strong material when we consider its weight to strength ratio. Okay, it's quite a good material there. Where would I see this being used in an actual project? If I'm thinking like major work level projects, for example, this is a great project to be used for a draw base where the visual appeal is not important. Another great space this could be used would be the back of an entertainment cabinet, okay, to stop things falling out from the back, where visual appeal is not something you need to consider. You just need a solution that closes it off, okay, but doesn't necessarily need to be made from a solid piece of jarrah, for example. Okay, so that's where I can see MDF being used. Where does it get used out in industry as well? Kitchen cabinets, okay, the doors on kitchen cabinets and kitchen cabinets themselves are quite often made from a fiberboard, okay? Sometimes a chipboard, but also very commonly fiberboard. It's quite a cheap product because it's made of offcuts, okay? And one of the real benefits here, okay, if we're thinking about benefits, it doesn't have to look as ugly as what you see on the screen. It doesn't need to look like fiberboard because you can apply a veneer to it. You could paint it, of course, but you can apply a veneer to it. So you could apply a solid veneer over the surface to make it look like a solid board, but have all the benefits of the strength and the cost effectiveness of MDF. Just like they do for kitchen cabinets, you could even vacuum form some thicker polyurethane coatings and things like that over them. So you're not just limited to the raw MDF look. Okay? It's definitely something that can be enhanced, but you get the benefits of the MDF on the inside. Now let's have a look at how it gets made. I'm going to turn my little laser pointer on here so we can have a look. The logs, okay, trees go and get chopped down. They get debarked, put into a chipper. Now, let me just point out here. They're probably not going out and just cutting trees down just to make MDF. Okay? They might have some plantations, but many companies, if they're looking at sustainability, MDF might be one of the products the company makes, and so they might use their leftover logs that couldn't be used for solid boards and throw them into the production line here. So the bark comes off, and then they go into a chipping machine. They get chipped, cleaned, chipped again, and put into basically this big boiler where they get cut into smaller pieces. The fibers get cleaned. They get They get made smaller again, they get cleaned again, they get dried again. There's a whole heap of processes happening where they're converting these fibers to get them into the format that they need. Okay, what you need to know, logs go in, they get chipped, they go from whole log sizes down to chip size, down to tiny little fibers. Okay, and it happens during the digester process. Okay, they quite often add waxes and resins in at this point as well. Okay, to try and add a little bit of strength and durability to the timber. You got to imagine MDF is a little bit like cardboard. You get it wet and it expands, very susceptible to water damage. So one of the things that gets added is wax to try and prevent that water damage. Doesn't completely make it waterproof, but it definitely helps. Then it comes down to this side and they get turned into mat formation. Okay, so we're talking these really big piles essentially of fibers. Okay, imagine like a bed mattress size. Okay, king size bed, that thick, that wide, that long. Okay, nice and soft and fluffy because it's filled with air. Then it goes through the hot press process where it actually gets put through rollers and it gets squashed down and compressed into this really dense board. So that nice fluffy pillow sort of mattressy sort of mat that gets formed is squashed down into these tiny boards that are much thinner. They then go across the saw, get cut, okay, trim down to some sizes, maybe trim off excess edges and give a nice straight edge. They go into the board cooler. I know this looks like a fan, but you put one board along one of those little blades there, and it actually rotates round. And then when it gets over to this side, it drops off and then joins on the conveyor belt again. To this point, sanded, sized, graded. So there's people there, or possibly even robots these days. But generally speaking, people there looking at the quality of these boards, determining what grade they are. Okay, determining their sizes, determining their finishes, and they get packaged off and sent along the way. Okay, so that's the production process of MDF. Have a think about this one because when we go off to chipboard later on, you're going to see that the process is quite similar. So MDF is there. If I summarized it for you, timber pulp, high pressure, basically exploded down in that high pressure to make the fibers. Heated and steamed so they become nice and fluffy, made into beds, they're glued together, compressed, cut into sheets, sent off to the shop. Next one is plywood. You've probably heard of plywood. I hope you have. We've used it in a couple of projects before. Plywood is made from layers of ply. So if I have a look at what I've got on the screen, you can see that light color there across the top. Then there's a slightly darker color, and then the light color again, then the darker color. So it's a repeating pattern there. It's actually the same species of timber in this case. This is probably a pine plywood. What you're seeing across the top layer is the side of the board. In the second layer, you're seeing the end grain. Then you're seeing the side of the board. Then you're seeing the end grain. Then you're seeing the sideboard. Then you're seeing end grain. So it's alternating the direction of the grain. And that's because whenever you see end grain here, the layer above it, the end grain is actually on the other edge. Now I know you can probably see these little rings there, and they probably look like growth rings. I'm really sorry that that's in the image, but that's actually marks coming from the circular saw blade that's cut these. So don't be deceived there. Light color is the side and end grain. So what they do is actually lay effectively sheets of veneer, okay, over top of each other, but they swap them around. So one is pointing one way, they turn it 90 degrees to get the second one, and then put the other one back, the third layer on top. The fourth layer they turn 90 degrees, the fifth layer on top. The sixth layer they turn 90 degrees, and so on. The benefit of this alternating grain is there is a huge increase in strength. Now, if you've ever held a piece of veneer before, a single sheet of veneer, you would know that it's quite flexible in its width and very brittle in its length. If you got two pieces of plywood over top of each other, facing the same direction, it would be a little bit stronger in its width and a little bit stronger in its length, but it's not perfect. If, however, you got two sheets of plywood, lay them together and alternated the grain direction, you would actually find that the grain changing direction has an enormous benefit in terms of the strength there. Now, when we're thinking about plywood, I'll go through the production process later, but we're thinking about plywood, they use various grades. If you're working in the construction industry and you just need a piece of plywood to use temporarily, you're probably going to be using a really low grade board, like a D grade board, for example. Okay, in a D grade board, you've probably got defects on both sides. You've probably got enormous holes in them. So where knots used to be, the knots have fallen out of the veneer and haven't even been filled back up again. Okay, so we're probably using really low quality boards, low grade boards. When you work your way up the grades, the quality of the surface board, so the front and back boards, increases. So when we're looking at C graded boards, there might be some knot holes that have actually been filled with a bit of putty. You're looking at B boards, there might be some knot holes, but they've still got the knots in them. You look at A boards, you may not even have knot holes at all. Okay, so there's a whole process that goes through in grading. But essentially, the board on the top and the board on the bottom is graded visually to try and determine what the grade of the plywood is. If you're thinking of using plywood in a furniture application, then you're probably going to be looking at a B or an A grade board. Anything lower than that is going to be a little bit too rough for you. And if you're thinking about, oh well, plywood, yeah, it's cheap enough, and it's got the right strength and it's the right size for me to use, but I just don't like the species. I don't like pine. I don't want it to be made from pine. Just like MDF, you could actually put a veneer over top of this. And I've seen it done plenty of times. Tassie oak coated or Jarrah coated pine plywood boards on one side only. So on the outside of your project, looks like it's made from Jarrah. Rest of your project is actually made from plywood. So it's sort of faking it there in a sense. Plywoods, they come in nice large sheets just like MDF, okay? A standard sheet, if you went off to Bunnings to grab one, you'd be looking like 1.2 meters wide, 2.4 meters long. But there are different sizes you can get there. How are these ones made? Well, trees are grown in the forest. Then the log is debarked, so the bark comes off. Then they're cut into smaller blocks that can actually be worked with. So instead of being 6 meters long, they might be cut down to, 1 meter, 1.2 meter long, or 2.4 meter long. Then the log actually is rotated against a blade and it peels off these veneers. Same way the veneer is created, it's exactly the same process, okay, but it's peeling the log. Then the sheets of veneer go through a cutter. The cutter drops down and chops them into the right sizes. Each piece of veneer goes through like a little oven to dry them out, just to make sure that they're not green anymore, okay, get that moisture out of them. Then they go through, they get spread with glue and laid on top of each other. Now remember, when they get laid on top of each other, that grain is alternated. Then they get put into the hot press and squashed all the way down, so under pressure to heat it and cook the glues in it. Sanded, cut to size, packaged, sent off to the shop. Okay? Nice simple process there. Not made from wood chips, made from actual solid veneer pieces as they are being peeled off a log. Particle board. This is the one that I said is quite similar to MDF. Similar because it's made from wood chips, dissimilar because it's much larger pieces. We're no longer working with fibers, we're actually working with chips. So in a particle board, we have two main types of chips. If you have a look here, you've got the inner chips. You can see they're quite large, quite rough. And then you've got the surface chips, top and bottom, which are much finer. This is done intentionally. The large chips on the inside, they give you a whole heap of strength. The small chips on the outside help to give you that nice smooth finish and also help to protect the timber from water damage. Again, not waterproof, but definitely some layers of wax are added to them to try and coat them to prevent that water from damaging them. You have probably got chipboard in your house somewhere right now if you went and had a look. Now, I'm just having a look around the room that I'm sitting in now, my little home office, and I can tell you that I've got chipboard being used in the cabinets of my laundry. Okay, a very old cabinet made from that. If you're thinking about your cabinets in your bathroom, very likely that those are made from a chipboard as well, and it's probably got some sort of laminate or plastic coating over them to prevent that water damage. Okay, but if you've got chipboard and it's a little bit old, you would know that it starts to sort of expand over time if the surface has been damaged and water has gotten in, then it actually really expands to a much larger size. So really susceptible to water damage there, but again, quite cheap. Particle board is really heavy. So if I'm thinking about my experience working with this, I find that this is probably the heavier of the three materials to work with, because you're working with wood chips, and even though plywood should technically be heavier, the the particle board is deceptively heavy for its size. Okay? You're probably familiar with yellow tongue if you've worked in construction or if you're doing the construction course as well. Commonly used as a subfloor surface cover. So if you've got carpet at home, you lift it up. If you're not on a concrete slab, it's probably laid down over particle board. It may also be sitting underneath any floating floorboards that you might have. Also, people put it up in their attics as well to put a little bit of flooring up in their roof space to help storage. So you probably come across that a couple times as well. Now, Yellow Tongue is a trademark brand, so it's not a type of particle board. It's just a brand, but it's something that people are fairly familiar with. Let's have a look at how it's made. The forest grows the trees. The trees are cut into small pieces. They're debarked and they're flaked. Okay, so put into little chips, tiny little chips. Not a big wood chip like you'd put in your garden. Okay, so definitely not that big. Definitely smaller than that, but not so small that it's a fiber. Cut up into the little flakes. They go through a drum and get dried off. The flakes get mixed with glues, some form of resin usually. They get laid out into mats. Okay, kind of like the MDF. Nice big mats, big fluffy at this point. They get put into the hot press where they are squished all the way down to their final size, sanded, trimmed to size, added into the pallet, packaged, sent off to the shop. Okay. So there you have it. That's the end of our series there on manufactured boards. You've got a range of manufactured boards. You can probably describe how they're made and some of the benefits there. Probably also have a think about where you could use them in your major works. So hope that's been helpful, and I look forward to seeing you in our next video. In our next video, we actually move on to fittings and allied materials. So that's actually the end of the materials chapter of this section here, in terms of timber and timber products. And we now move on to fittings and allied materials. That's where we look at hardware and other materials used within our projects. Thanks very much, and look forward to seeing you then.